Good evening, friends. In this lecture, we shall be discussing about DC circuits and to begin with, how to do a mesh analysis in DC circuit. So now you can see on the screen, given a question, there is a circuit comprising of several DC sources, that is more than one DC sources, and one is required to find out the current in each mesh using mesh analysis. So let us see how we shall be able to solve this circuit using mesh analysis. Now mesh analysis, now what do you mean by this term mesh? The meaning of this term mesh means it's a loop. It's a loop. So loop can be a closed circuit. Of course it is a closed circuit. Now mesh means it is the smallest loop. So whenever we refer to this word called as mesh, it refers to the smallest loop that is present in the circuit. Yes, prior to we move to solving these circuits, are you aware of this fact that there is a difference between a circuit and a network? Over here, I am speaking out that it is a circuit. A circuit means it has to be a closed path connecting various elements. And what are the elements in our electric circuits? The elements are the sources and passive elements like R, L and C. So far we'll be considering these as our elements. In our further studies we shall come across various other elements as well. So a circuit is a closed path connecting all these elements. Now whenever you come across a circuit will have a smallest closed path as well as a bigger closed path. That smallest closed path or the smallest loop is called as a mesh. And the analysis when we carry out for that smallest loop is called as mesh analysis. Now mesh analysis, there are a few points that we need to remember before we begin on with the mesh analysis approach. Mesh analysis is based on the concept of KVL. As you all know, this KVL stands for Kirchhoff's voltage law. So you have to write, or one has to write the equations in the circuit based on this Kirchhoff's voltage law. And if it is since it is based on KVL, that clearly means there is a conservation of energy. There is one more aspect of this mesh analysis, that it is applicable only to planar circuits. What do you mean by planar circuits? Circuits that can be drawn on a plane. Or you can, in other words, you can say circuits that can lie on a 2D plane. If the circuit does not lie on a 2D plane, then it is not possible for us to apply mesh analysis. So these are the two important aspects one has to remember before applying mesh analysis, that it works clearly on the principle of KVL, that is Kirchhoff's voltage law, and second thing is it's applicable only to planar circuits. So let us begin with how to solve our circuits using mesh analysis. Now there are certain steps that one has to follow before beginning with the solving procedure. The first one is identify the mesh. Now what do you mean by the mesh over here? Identify the smallest loop that is present in the circuit. Second is name the circuit. The third part is assign a direction of current in every mesh. Now why do we say this, that you assign a direction of current in every mesh? Because in mesh analysis one has to encounter more than one voltage sources, which means you have multiple voltage sources and one has to figure out the mesh currents in the circuit or the branch currents in the circuits. So in order to figure out the mesh currents or the branch currents, you have to assign the direction of current in every mesh. The fourth step is apply KVL in each mesh. Now how do you apply KVL in each mesh? What does KVL says? KVL says that the summation of the voltage drop across each element around a closed path should be equal to 0. That is, summation of I into R is equal to 0, or summation of the potentials or the voltage sources present in the circuits is equal to 0. Apply Ohm's law to express the branch voltages in terms of the mesh currents. I repeat here once again, apply Ohm's law to express the branch voltages in terms of the mesh currents and the resistances. And finally, you have to solve the simultaneous equations in order to get the final mesh current values. Now let us solve a simple DC circuit and let us apply our mesh analysis approach. Once we are done with this, we can apply the same concept to the numerical that was shown in the first slide. Now this is a basic circuit that I have taken over here. Now you can see, now first thing is, let us first identify the mesh. Now what does the step says? The step says that identify the mesh. So how many meshes can you see in this circuit? Clearly, meshes means the smallest loops present in the circuit. We have two loops over here, two smallest loops. Now if you consider of the loops, then there are three loops. Now first name the circuit. Name the circuit in order to identify how many loops are present. Now if we talk of A, B, C, D, E, F, A, then of course that is one of the loops. But it is not the smallest loop because this loop has got loops present within it. So this is not a mesh. This is a bigger mesh, but not a mesh having the smallest loop. Whereas look at these loops like A, B, E, F, A, or look at the loops B, C, D, E, B. Are these the smallest loops present in the circuit? Yes. So of course these are called as mesh. Now we have to do our analysis on these meshes and find out the mesh currents. Once you know the mesh currents, we'll be able to find out the current flowing through each branch. So we are done with step 1 and step 2. Step 1 says identify the mesh. We have already identified there are two meshes. So we have to find out two unknown currents. Second thing is name the circuit. That is already being done. So from the naming of the circuits, we could figure out what are the meshes or loops present in the entire circuit. Now what is step 3? Step 3 says you have to assign a direction of the current in every mesh. Now look over here. This is a very important part while solving. Now whenever you are solving the circuit using mesh analysis, always assign the direction of the current in the clockwise fashion. Make it a habit and always assign the direction of the current in a clockwise fashion. Never make a habit of assigning the direction of the current in one mesh in the clockwise manner and in another mesh as in anti-clockwise manner. You might be able to solve the circuits correctly, but for the ease of simplification, keep the direction of the current same in all the meshes. For my convenience, I consider the clockwise direction to be more convenient. If you are not comfortable with the clockwise direction, you can also go with the anti-clockwise direction. But once you are going with the anti-clockwise direction means all the meshes will have the anti-clockwise direction only. No combinations of clockwise and anti-clockwise directions are to be entertained when you are solving one particular circuit. So I'll go with my analysis approach, that is we'll be going with the clockwise assignment of current. So there is a clockwise current flowing in this mesh, there is a clockwise current flowing in this mesh as well. Now the fourth step says apply KVL to each mesh. And how do you write down these KVL equations? In order to write down the KVL equation, one has to use Ohm's law in order to express the mesh voltages or the branch voltages in terms of the branch currents and their respective resistances. Now this is a very important aspect. Please follow this part. Now as we can see, A, B, E, F, A is the first smallest loop, or from here onwards I'll be calling it as a mesh. So A, B, E, F, A is a mesh and we are supposed to write the KVL equation for this mesh. The assignment of the current is in clockwise direction. Next is you have to write the KVL. Now what is the analysis of approach? Let's look for it. Always start writing your equation in the clockwise manner. Try to write your equations from this corner onwards and take a loop which starts like this, goes through the resistances, these resistances, voltage sources, and back again to the starting point. So this is the standard concept that I refer to while solving the circuits. So remember two things. The assignment of the current should be in the clockwise fashion, and while writing the KVL equations, please go around the mesh or the loop in the clockwise fashion only. So clockwise should be your assignment of current and clockwise should be the approach of writing your KVL equations. So both should be clockwise. Now let us begin with writing our equations. Now what is KVL? KVL says that the summation of the potential drop across each element around a closed loop is 0. How many elements can you see in this mesh, in the first mesh, that is A, B, E, F, A? I can see there are 4 elements. 1, 2, 3, 4. So for the first mesh, the summation of the voltage drops across these 4 elements will be equal to 0. So our first KVL equation will comprise of 4 terms. Since there are 4 elements, we will naturally have 4 terms, and each term, by term I mean each element. Now there are 2 things. While encountering the elements in a particular mesh or a loop, there are 2 types of elements that one can encounter. The first thing is you can come across a voltage source itself, and the second thing is you can come across a resistor. These are the only 2 ways in which you can write your KVL equation. If a voltage source is coming into picture, you can directly write the voltage value, and that serves the purpose of a voltage. And if you are coming across a resistor, then the current across that resistor multiplied with the resistor gives you the voltage value. So these are the only 2 ways in which your every term has to be written. Either it can be a voltage source, so it will directly take the voltage value, or it can be expressed in the terms of current flowing through a particular resistor multiplied with its respective resistance. Now my analysis for writing the KVL equation begins in the clockwise fashion, and the assignment of current direction is also in the clockwise manner. So there are 2 aspects. Since there are 2 ways in which I can write the voltage equation, one is only for the voltage sources. Over here this voltage refers clearly to the voltage sources, or I can write it in the terms of the product of the current along its respective resistances. So whenever you come across a voltage source in a particular mesh or a loop while writing the KVL equation, then the last sign that is encountered should be taken as the voltage sign. Let's just see that for example. Now this is a mesh that we are considering, A, B, E, F, A. Now I start my analysis from here. Now here I will go in the upward direction from F to A. Now when I am going from F to A, what is the last sign of this voltage source that I am coming across? The first sign of the voltage source that I come across is a negative sign. The last sign is positive. So in the KVL equation, this thing will be written as plus 15 volts. Had this symbol been plus and minus would have been the last sign that I would encounter while going in this KVL direction, then I would have written here minus 15. Since the last sign encountered is plus, so I am writing here plus 15. Now let us move forward. Now while moving forward, I'll try to go from A to B. We only had 1 element, so we are done. Now secondly, for the branch A to B, we are moving from A to B, that is from left to right. Now what is the element that you are coming across? This is not a voltage source, rather it is a resistor. So for a resistor, how do you write this voltage equation? Current flowing across that resistor multiplied with its respective resistance. Now over here you have to see one thing. This is your analysis. You are going from A to B, that is from left to right. What is the direction of current across this branch? This is again from A to B, because you have taken a clockwise direction of approach. I am repeating this thing again. The KVL equations are being written from the point A to B, that is from left to right. And the second thing is the direction of the current or the current flowing through this branch is also from A to B. When both are in the same direction, the analysis is also from A to B, the direction of current is also from A to B. When both are in the same direction, we consider that to be a negative drop. So what will be your second term? Your second term will be written as minus, what is the current that is flowing through it? We have not assigned any value of the current so far. So let us write that as I1 and this as I2. So what is the current that is flowing over here? I1 times, what is the respective resistance? That is 5. I hope this is clear. Now we can make this again clear by trying out this resistance. We are not yet done. We will have 4 terms in our KVL equation. So next what will happen? Our analysis will now move from B to E. Now one has to see over here, B to E has got 2 elements. The first element that is being encountered is a resistor. And now what is the current flowing through this resistor? It is not just I1. It is I1, some part of I1 as well as some part of I2. So how do you write this thing? First thing is your analysis is going from B to E. At the same time, the current flowing through this branch is also flowing from B to E. from I1's point of view. Do not take into consideration I2 now, because we are considering the first loop. And since you are considering the first loop, you should take into account only that current which is flowing through that loop. You should not be concerned about the other currents that are present in other loops. So for this loop or the mesh I1, from B to E, current I1 is flowing from B to E. So the direction of current is from top to bottom, as well as our analysis is going from B to E or top to bottom. Since both are in the same direction, it is a negative drop. So what can I write? The equation becomes minus, let me first write the resistance, that is 10 I1. The current flowing through this branch is I1. But is the current flowing through this branch is I1 only? No. I2 is also present, coming in the opposite direction for this particular branch of particular element 10 ohms. And why this I1 comes first? Because this is the parent loop for which we are writing the equation. Now when you start writing the equation for the second loop comprising of the current I2, you have to take I2 first followed by I1. You are coming across a voltage source. Now for voltage source, the concept is whatever is the last sign encountered, that would be the sign of the voltage. So it is minus. So what should we write here? Minus 10 is equal to 0. Why is it equal to 0? Because there are no more elements present. So the loop can be extended forward and finally we reach to our starting point. So this is how you write down a KVL equation. Now let us try writing the KVL equation for the second mesh. Now let us see how will we write. Now according to our concept, the assignment or the direction of current has already been in the clockwise fashion. Now we shall start writing the equation from this leftmost corner and we'll begin in a clockwise fashion. So what is the first direction that we are going to go? That is from E to B. Upon traveling from E to B, there are two elements that we are going to encounter. What is the first element? The first element is the voltage source. Now see, the concepts whatever we learned right now, how to write the voltage equation and how to write the current multiplied with the resistor equation would remain the same for any number of loops that we have. The only thing that you have to remember is, if it is a voltage source, the last sign encountered will be given as the voltage value, and if it is a current source, then you have to check your direction of analysis and the direction of current. If both are in the same direction, it is a negative drop. If they are not in the same direction, it has to be considered as positive. So this is the first element that we come across, that is a voltage source. Now what is the last sign encountered? It is plus. So it will become plus 10 volts. Now you can drop this V as well, because I'm just writing for the sake so that you understand that the value of the voltage is given in volts over here directly. So we are writing over here. Otherwise you can drop this as well. It's not necessary to write. Now what is the direction of current flowing through this branch E to B for the second mesh? Just look into the second mesh. Whenever you are writing the equations for a particular mesh, put your entire focus onto that mesh. You should not be worried about what is happening in the neighboring meshes. So for this mesh I2, the current in the branch EB from E to B is flowing from E to B. So my analysis of approach is from E to B and the current is also flowing from E to B. That means it's a negative drop. So what will be my equation? Minus, first write the resistances values, because here you will have two current values. Since this branch is also carrying some part of the current of the adjacent mesh as well. So first write the resistance value, that is 10 into I2 times. Since this is the I2 loop, the parent loop is for the I2. So first write I2 minus. Why minus? Because I1 and I2 are not in the same direction. I2 is going from bottom to top and I1 is coming from top to bottom. So minus I1. So this is how you will be writing the current multiplied with the resistance equations. Now let us move on to the next element. We will be traversing from the point B to C, and the element that we come across is again a resistor. So find out what is the current that will be flowing, or what is the assumption of the direction of current that would flow through this particular branch. It is from left to right, and our direction of writing the equation is also from left to right. Since both are in the same direction, it is again a negative. So it will be minus 6 times I2. There is no other current that will be flowing through this element. Next, since we are going in a clockwise fashion, we'll travel from C to D. We are going in a clockwise fashion across this particular mesh from C to D. We are traveling from top to bottom. Look at the direction of the current, that is only I2 is flowing through this particular branch or through this particular element, and that is also flowing from top to bottom. My analysis is also from top to bottom. Branch current is also flowing from top to bottom, so it will be a drop. So right here as minus 4 times of I2. Next, are there any elements present? No, there are none. So you can now close this KVL equation, because all the summation of the voltage drops that you come across a closed loop is equal to 0. So these are your two sets of KVL equations that you shall be writing. Once you have written the equations, that is half of the work is done. But the important aspect after writing the equation is you must know how to carry out the analysis, or how to carry out or figure out these values of I1 and I2. That is more important. So I am rewriting the equations over here. The first equation was, now with practice you shall get to know how to write these equations. Now over here you have to remember one thing. The moment you write down this particular equation or the KVL equation, try to simplify the equation and write it in the terms of I1 and I2 and bring the constant to the right hand side. Please remember this part, always bring the constants to the right hand side. Now there is an important part about this. Constant means no unknown variables associated with a particular number. Now will every equation have a constant associated with it? Not always. If for a particular mesh considered by us has a voltage source in it, so there definitely will be a constant. If a particular mesh has no voltage sources, then your constant term will be 0. Now let us go to the previous slide. Now look over here. This is our given question. Consider the first mesh A, B, E, F, A. Consider the first mesh A, B, E, F, A. Are there any voltage sources present in this mesh? Yes, there are 2. So definitely there will be a constant term. Consider the second mesh B, C, D, E, B. Are there any voltage sources present in this mesh? Yes. So obviously it will also have a constant term. But when we'll start solving more and more number of numericals, you will see there will be many loops or many meshes which will not carry any voltage sources. In that case, that constant part will come out to be 0. So simplify this equation. Please club all the terms that have I1 together. So it becomes minus 15 I1 plus 10 times of I2. Take all the constants to the right hand side. So it becomes minus 5. So this is the simplified version of equation 1. Yes, there is one more thing that you have to take into consideration. I have kept this minus sign along with the term I1, and I have also kept the minus sign with the constant. It does not make any difference, because eventually you have the liberty to use your calculators in your examinations. I'm talking about your annual examinations or in the university examinations. Whereas for the gate level examinations, you will be given with a virtual calculator. That part we'll discuss it later. But as of now, you have your calculators with you. So keep the minus as minus itself, keep the plus sign as plus itself. Do not try to change these signs. Now let us look for the second equation. The second equation I had written over there is plus. So if you start simplifying this equation, what does it become? It's bring all the terms of I1 together. So it is 10 times of I1 minus 20 times of I2. Please bring the constant to the right hand side, so it becomes minus 10. So this is a simplified version of the second equation. Now use your calcs to solve this simultaneous equation. In case you do not know how to operate your calc to solve these equations, your calc, your scientific calculators always has a button called as a mode option. Click on the mode option, go to the equations. Over here the number of variables that we need to solve are 2, because we have 2 unknown variables I1 and I2. Once you press the number of options as 2, because you have got 2 unknown variables, insert these values in your calc and press answer, and you'll be getting the final. In case you do not know how to operate this part, you can please write it in the comment section and I can make a video on how to solve these simultaneous equations using scientific calculators. So after solving these simultaneous equations using scientific calculators, so these are the answers that you shall obtain. I1 shall come out to be 1 amps and I2 shall come out to be 1 amps. Now let us move on to the question that was being asked in our first slide. So now you already know the basic idea of how to solve these equations using mesh analysis. So first thing is you need to identify the meshes. If I ask you how many number of loops are there, then naturally there are more than 3. It's a task for you to find out how many loops are there, how many loops are present in the given circuit. But meshes, if you talk of meshes or the smallest loops, then certainly there are 3 meshes over here. So there will be 3 mesh currents, 3 unknown equations, so 3 simultaneous equations. Now this feature is also available in your scientific calculators. You can solve up to 3 unknown variables. Some advanced calculators also allow to solve 4 unknown variables, but we will be considering only up to 3 unknown variables. Okay, there will be 3 meshes, 3 smallest loops that are being identified. Let us go to step 2. You must name the circuit. So the naming part is done. So what are the meshes for which you are supposed to write the equation? So first mesh is ABGHA. The second one is BCFGB, and the last one is CDEFC. So there are 3 meshes or 3 smallest loops, and we have to write our KVL equations for all the 3 meshes. Assign the direction of current in each mesh. As usual, we'll go with our clockwise direction analysis of approach. Name the currents as I1, I2 and I3. Now for the first mesh, please start writing your equation from the left hand side corner, and our analysis will go in the clockwise fashion. So what is the first element that we are encountering? It's a voltage source. For the voltage source, we have to consider the last sign. So last sign over here is plus. Now yes, please make sure, or please remember, the small bar means it's a negative terminal and the bigger bar represents the positive terminal. So what is the last sign that we are encountering when we are traveling from H to A? It is plus. So plus 10. The second element is the element 6. That is a 6 ohm resistor. Now we are traversing from A to B. The direction of the current along this branch is also from A to B. So both are in the same direction means it's a drop. Value of the resistance is given as 6, and what is the current? I1 only. Third branch, we are traversing in the clockwise fashion, so we are traveling from B to G, top to bottom. Over here, this branch is common to both I1 and I2. But our analysis of writing this KVL equation is with I1 only, with this loop. This is our parent loop that we are considering right now. So we are traveling from B to G, and the direction of current is also from top to bottom. So again it's a drop. So it's a minus sign. Write down the value of the resistance, which is 1 ohms. Since this is a common branch to I1 and I2 both, to mesh I1 and mesh I2 both, I1 is in the top to bottom direction for this branch and I2 is in bottom to top direction for this branch, are not in the same direction, so it will be I1 minus I2. We'll travel from G to H. There are no elements encountered, so this becomes our first equation. Second equation, our analysis starts from the left hand side corner, and our second mesh is BCFGB, and our parent current is I2. You should not be focused on looking for the current I1 or I3. Over here, you should only focus on the current I2. Now when we'll travel in the clockwise fashion, we'll first travel from G to B. When we are traveling from G to B, the current flowing through the resistor 1 ohm is I2, and that is also traveling from G to B. So it's a drop. Minus the current resistance value is 1. What is the current? I2. But since I2 is not the only current that is flowing through this branch, and there is current I1 as well, now let us check the direction of I1 in terms with I2 for this particular branch. And the direction of current I2 is also from bottom to top. Both are in the same direction, so it's a negative drop, which I have already considered. But I1 is flowing from top to bottom, so it will be I2 minus I1. While traversing from B to C, we encounter another resistor. And this is for this resistor, current I2 is flowing through it, and it is not a common branch to any other mesh. So we are traversing from B to C. The current through B to C is also flowing from B to C. Both are in the same direction. It's a drop. So minus 2 times of I2. Moving ahead, we'll traverse from C to F. So we come across a resistor. Now when we come across a resistor, we again have to look for the current direction. We are traversing from C to F. The current through this element is also flowing from C to F. Since this is a loop written for the I2 current only, we have to look for the current I2. So I2 is flowing from C to F and we are also traversing from C to F. So it's a drop. So minus 3 times of I2. Now since this branch, by what do you mean by branch? Branch is any path containing an element. Now this branch CF is common to the loop I2 as well as I3. So we have to check the direction of I3. Is it in same direction as that of I2, or is it in the same direction, or is it in the opposite direction of I2? Now we can see I2 for this branch C to F is flowing from C to F, but I3 for this particular branch is flowing in the opposite direction. I2 is from top to bottom, I3 is from bottom to top. And now since the parent branch or the parent loop mesh for which we are writing the equation is I2, so I3 will come with a negative sign. Moving ahead, we'll travel from F to G. There are no elements encountered, so we'll complete our KVL equations by equating all these terms to 0. Now coming to our last mesh, that is CDEFC. We'll begin our analysis from the leftmost corner, that is FC. We'll traverse from F to C because our analysis is always in the clockwise manner. While traveling from F to C, in this branch we come across an element, that is a 3 ohm resistor. So look out for the direction of current. Since we are writing the equations for loop I3, then we should only look for the direction of current I3. The rest common branch currents can be taken care of later on. Or our analysis is from F to C and the current I3 is also flowing from F to C. So both are in the same direction, so it's a negative drop. So it's minus 3 times of I3. Now since this is a common branch between I2 and I3, so it will be a minus. Why it is a minus? Because for this particular branch CF, I3 is from bottom to top, whereas I2 is from top to bottom. So they are in opposite direction. So since we are writing our equations all in terms or with respect to the direction of current of I3, I2 will bear this negative sign. Now moving ahead, we will traverse from C to D in the clockwise direction. There are no elements, so there are no terms to be incorporated over here. And let us move from D to E. Now while traveling from D to E, we come across another resistive element, that is a 10 ohm resistor. Now look for the direction of current across this element. Now we are traveling from D to E, that is from top to bottom, and the current that is flowing through D to E, which is I3, that is also from top to bottom. Since both are in the same direction, it will be a minus or a drop 10 times, that is the resistor value, into the current. There are no common branches, so it will be only I3. Now let us move ahead from E to F. Are there any elements present? Yes, there is a voltage source present. So for voltage sources, our concept is whatever is the last sign encountered. Now the larger bar represents the positive terminal, small bar represents the negative terminal. Now while traveling from E to F, what is the last sign that is being encountered? Minus. So it's minus 20 volts. We will not write V. Minus 20 is equal to 0. So we have got all our three equations, 1, 2, 3. Let us simplify these equations and let us get the final answers. Our first equation is, simplify it. So bring all the terms of I1 together. So it is minus 7I1 plus I2. Now there is something that you have to remember. How many unknowns are there in this equation? There are 3 unknowns, I1. However, for the first equation, we do not have any term of I3 coming into the picture. So what happens is, generally students forget that there is I3 being involved, and while inserting the values or while substituting the values in the calculator, they make certain mistakes. So since there are 3 unknowns, even though I3 is not appearing in this equation, either leave the space blank, or for your reference you can write over here plus 0 times I3, such that you remember that there is an unknown variable I3 also present in the circuit or present in our analysis, and its value is 0 for the first equation. Now is equal to minus 10. Now for as you remember why this constant term is coming, because for the first loop we had a voltage element present. Now coming to the second equation. The second equation is simplify all these equations. The final equation will come out to is equal to 0. Now why this thing came out to be 0? We'll go to the previous slide to have a look. Now look for the second loop, that is B, C, F, G, B. Are there any voltage sources present for this particular mesh? None. So whenever you write the KVL equations, there are no constant terms. You'll only get terms with the unknown variables, no constant terms present. Look for the first mesh, A, B, G, H, A. Are there any voltage terms present? Yes, so you will have a constant term. Look for the last mesh, C, D, E, F, C. Are there any voltage sources present? Yes, 20 volts. So definitely you will have a constant term present. Now we're moving on to the last equation. Upon simplifying, now look over here. For the first equation, I3 term was missing. For the last equation, I1 term is missing. So please make sure either you leave the space blank, because while inserting the values in your calc, you should know which values are to be inserted for which unknown variables. Actually, your calculator creates a matrix, and if the matrix values are given incorrect, you will obtain an erroneous results. So since there are no I1 terms present over here for the third equation, either leave it blank or write it as 0 I1, whatever is convenient for you. Then start writing plus 3 times of I2 minus 13 times of I3 is equal to 20. Since there was a voltage source present, so we got this value as 20. Now solve these three sets of simultaneous equations using your scientific calculators, and these are the final values that you shall be obtaining. I1 will come out to be 1.34 amps, I2 will come out to be minus 0.62 amps, I3 will come out to be minus 1.68 amps. We come to the end of this mesh analysis concept. This is the basic approach of how to solve the circuits using mesh analysis. For your practice, there is a practice set being given in the description. You can click on that and try to solve these questions. You can post your answers as comments, and if you have any query, you can also ask your questions or your queries in the comment section, and I'll try to solve these questions in the upcoming videos. Thank you.